Let's talk about parallelograms. Parallelograms are clearly quadrilaterals, but the opposite sides are parallel, which means we can go ahead and label that. And there's a way to actually label parallelicity, parallelness. It's this. Little arrows that are like, hey, yeah, they're going the exact same direction. And we can do this here as well. We're going to put double arrows on these, just not to be confused with that. Clearly they're not going to be confused with that, but for correctness, we need to have a different number of arrows on those. Okay, so there's that. That's just the basic definition of a parallelogram, but now we also got to talk about some other things. So the opposite sides are congruent. Now we're going to prove some of these things later in this lesson. We're going to be like, well, how do we know they're congruent? Well, I mean, just look at them. They look congruent. And that's not a good enough proof, right? We've got to really say, okay, this is how I know. We'll get into that. In the meantime, take my word for it for now that this side is equal to this side in measure, and that this side is equal to this side in measure. Okay. Also, the opposite angles are congruent, which means, let's do this. This angle is equal in measure to this angle, and this angle is equal in measure to this angle. Okay, still with me? Sure hope so. Then we're going to have consecutive angles that are supplementary. And you'll see where this one's going. I'm looking at my notes to do these in the correct order. But basically, if I have, I'll address it more later, but if I had two parallel lines that are cut by a transversal, we've been through this, or in other classes you've been through this, the alternate interior angles, angle 1 and angle 2, would add up to be 180 degrees. That's exactly what you have here. You have parallel lines cut by a transversal that I missed. There's an angle, there's an angle. They're going to add to be 180 degrees. So I'm not going to show that any other way. There we go. And then the last thing is that the diagonals bisect each other. And I want to show that with blue. Actually, let's show it this way. It's going to be more interesting if I show it with this. So we're going to do that. And we're going to do that. And doing that means that I am able to now label these as congruent. So this side is congruent to this side. Now I've used 1 mark, 2 marks, and 3 marks. The next obvious one will be 4 marks. Actually, I'm not. I'm just going to put like an X, not as a variable, but just some little mark to show that those are congruent as well. Okay, now let's get into the nitty-gritty. What if I have a parallelogram, but all 4 sides are equal in measure? Well, now I have a rhombus, and that's what I'm dealing with here. There are some properties of a rhombus. So the parallelogram with all 4 sides congruent, called a rhombus, and the opposite angles are bisected by each diagonal. What? Okay, glad you asked. Let's draw those diagonals again. We'll do it here. We'll do that one, and we'll do that one. And the opposite angles are bisected by each diagonal, which means this angle up here was cut in half. Well, in a parallelogram, opposite angles are congruent anyway. So if those were cut in half, then these are cut in half as well, and they are the exact same as the others. And then same here. Double swoosh, double swoosh, double swoosh, double swoosh. These were both cut in half as well. And the last property is that the diagonals are perpendicular to one another. So I will put a right angle right there. And we can also say that all the properties of parallelograms apply. So I could say, oh, well, these diagonals are bisected. Absolutely not going to go that far because we already had that up here with the parent quadrilateral. Okay, now we're going to get to rectangles, which is not going to be too tragically different, but you've seen this before, obviously. You've seen rectangles before. You've been alive. And all the properties of parallelograms are going to apply here, but now we're going to have another property that basically defines them as a parallelogram, as a rectangle, I mean. And that's where all 4 angles are 90 degrees. And one more thing. The diagonals, which will be blue, are going to be congruent. This diagonal equals that diagonal. Up until this point, all the parallelograms we've dealt with had diagonals that were not necessarily the same length. This one was shorter than that one, and this one was shorter than that one. Well, now they are the exact same length. And then, if you have a parallelogram with 4 equal sides, you have a rhombus. If you have a parallelogram with 4 equal angles, you have a rectangle. If it has 4 equal sides, 4 equal angles, then you have a square. A square, I'm not going to draw in this one, but it has all of the properties of everything that you have seen already in the ones that are up above it. So as we go through the chart that's on the notes, that it has like the quadrilateral, and then it has the parallelogram and the rhombus and the rectangle and the square, like everything has the properties of the one that's above it.